Welcome to section 3.7 entitled Angle-Side Theorems, where today we look at a relationship between the angles and the sides of an isosceles triangle. Our two theorems are this. First one says if two sides of a triangle are congruent, then the angles across from them are congruent. So in other words, if we have an isosceles triangle, we know that the legs are congruent, the angles across from them are going to be the base angles. Those must be congruent. So another way to think of it is, if legs of an isosceles triangle are congruent, then base angles are congruent. The other theorem is the exact opposite. It's the same idea, except now we know that the angles are congruent, and we're using that to show that the sides are congruent. So how does this work? Well, we've got a couple examples that we're going to work through today. The first one is an algebra-based problem, and it says here in the restrictions that the measure of angle O plus the measure of angle U is less than 180 degrees. And we know that OY is bigger than YU. So I'm going to mark that off in my diagram that OY is big. And that YU is small. I've got two inequalities that I'm going to set up. The first one should be very apparent. If I take O plus U, I'm going to be less than 180. So I have 5x plus 12 plus 12x minus 2 should be less than 180 degrees. Now I'm going to use that to find out what x has got to be less than. So 5 and 12 is going to give me 17x. 12 and negative 2 is 10. If I take 10 away from both sides and divide by 17, I get that x is less than 10. So I know that any number bigger than 10, I'm going to have a problem because my triangle is going to have angles that are bigger than 180. In addition to that, I know that OY is bigger than YU. So if this is my big side, then 12x minus 2 is my big angle. And if this is a smaller side, then that's a smaller angle. So I know that 12x minus 2 has got to be greater than 5x plus 12. I'm going to bring 5x over and 2 over and find out that x is bigger than 2. So my restrictions, I'm going to write this so that x is in the middle, and I know it's bigger than 2 and less than 10. So if it's any number in between 2 and 10, then my given information holds true. If it's bigger than 10 or less than 2, then I've got a problem. Well, the idea was big angles are across from big sides and small angles across from small sides. So a proof. Well, this would be a very relatively quick proof. We are trying to prove that we have angle E congruent to angle D, knowing that we have circle N. So again, you're given a circle. The first thing you should be looking for are what are my radii. So my radii are the segments that go from the center of the circle to the edge. So N is my center. The edges are E and D. So NE and ND are going to be congruent. So looking at that information right now, I know that I have two congruent sides, which means it's an isosceles triangle. But more importantly, it's going to help me prove that angle E is congruent to angle D. Because if I go across from this side, I get an angle. If I go across from this side, I get another angle. And those angles are the base angles. They must be congruent. So setting up my proof, I know that NE is congruent to ND. And my reason is all radii of a circle are congruent. In addition to that, so I'm going to start with my sides, and then I went to my angles. I'm on to step 3, which is that angle E is congruent to angle D. And here's my reason. If I know the sides are congruent, then I know the angles are congruent. If sides, then angles. Notice I did not prove the triangle's congruent. If I wanted to, it would be a much more complicated, involved proof to do that. But with the information given, that's the easiest way is to prove that the sides are congruent, and then use those sides to get the angles. So in a lot of cases, these theorems that we're covering today are shortcuts. Here's an important little tidbit. The largest side of a triangle is always across from the largest angle. Think about a right triangle. The largest angle is the right angle, and the largest side is the hypotenuse. The smallest side of a triangle is across from the smallest angle, and the middle side is across from the middle angle. So in this example, we've got triangle NOT. We know that angle N is bigger than angle O is bigger than angle T. We want to list the three sides in order of size from least to greatest. And the hint that we have is that we should probably draw a triangle. So let's go ahead and draw a triangle in. So let's pick a triangle. And I'm going to label it with the information I have, angle N, angle O, and angle T. And it says that based on this information here, N is the biggest angle. So I'm going to call this the really big one, really big angle. O is the middle angle. And then T is the small angle. We want to list the three sides in order of size from least, that means the smallest, to the greatest, which means the biggest. So if I use my small angle, across from my small angle has got to be my small side. It's segment NO. Across from my middle angle is my middle side, NT. And across from my big angle is the big side, OT. Big angle across from the big side, small angle across from the small side, middle angle across from the middle side. And that's how you're going to do a problem like that.